Hi! St. David's Day has come and gone for the year, so I think it's about time this week that we do a video with a bit more Welshness to it. So today we are going to be taking the national flower of Wales, the daffodil, and making it even more patriotic. But before then, roll the intro. For this one, we'll be attempting to put colour into the petals of the daffodils. For this, we first need to mix up our pigments. As this is our St. David's Day special, we're going to be attempting green, red and white. We have pigments for our red and green, but as an attempt to put white onto our daffodils, we're going to be attempting to use a dilute solution of sodium hypochlorite bleach. We now need to split the stem of the daffodil into three, so that it can be placed into three different solutions. The effect which we're hoping to take advantage of for this is known as capillary action, which can be demonstrated very easily using beakers of coloured water and paper towel. There are two main forces to be considered for capillarity: cohesion and adhesion. Cohesion is the force attracting like molecules to each other, so water to water. Adhesion is, on the other hand, the attraction between two different molecules. In this case, the water to the paper towel. If the adhesion is greater than the cohesion, the liquid will be drawn up the solid. Vascular plants have xylem. The surfaces of the xylem are very effective at encouraging adhesion, allowing the plant to take in water. But now we need to give our daffodils some time for that capillary action to take place. Three days later, this is what we're left with. All in all, it was not as successful as we had hoped. The red seems to have taken rather well on this daffodil. However, no sign of green, and the bleach was not pulled up the stem very far. We can see, however, on the stem of the daffodil, along the cut edge, that deep red which has been pulled up. I do believe, however, that one of the main factors which led to this daffodil wilting was that the red pigment we used contained sodium chloride, or salt. Here we can see the part of the stem which was submerged in a bleach solution, and we can see that it has lost its colour and become nearly translucent. Let's recreate this and take a closer look. If I put more bleach into another beaker and drop in a piece of stem, we'll be able to see this process taking place. The whitening of the plant stem happens due to a process called oxidation. The oxygen released by the bleach is breaking down the chemical bonds of chromophores, changing how they interact with light and not allowing them to provide us with that once vibrant colour. We decided to have a second attempt at this, but this time using warm water to encourage the coloured water to travel up the plants. This is what we ended up with. For some reason, this time the red pigment was nowhere near as prominent, and once again green hardly had an effect. But just for fun, we attempted one with blue, and that took excellently, and was by far the best example of this effect we produced. Let's take a look at these under the microscope, starting with blue. With the blue petal, the vascular system of the petal is clearly visible, and as the blue mixes with the yellow, we even get that desired green on the daffodil. Now onto the red. It is far less clear, but we can certainly still find areas of red throughout the petal. Lastly, with green, we can see very little, even under the microscope. We would suggest that if you want green on a daffodil, just use blue. And sadly that does bring us to the end, but please do tune in next week where we'll be looking about why it is so important to brush your teeth by looking at the bacterial cultures that grow in your mouth. But until that time, please do share, like and subscribe and carry on learning. Bye!